to add a constant. No. This is what I call looping. Yes?
Isn't it minus the negative cosine, so should it be plus s?
Well, there's three minuses. There's the minus that came from the original integration by parts, and there's the minus that's in the integration by parts 2 formula, and then there's the third minus from the integration of sine. I know, it's very easy to lose one of those. Sines, everywhere there's sines, what can I tell you? So there you go, this is looping, all right? Another example that's like this, that's kind of healthy to see. If we had integral of cosine squared theta d theta, we could do this one. Of course, you guys, we know another method to do this, right? We could just say, oh, half angle identity, we're done, right? But let's use this as an opportunity to try integration by parts, okay? So this is really integration of cosine theta d theta. So maybe this is a good problem for integration by parts, right? This is going to be my dv. This is going to be my u. I mean, what else could you do? So then I get what? I get uv minus integral of v du. What is that actually here? Integral of cosine is what? Sine, yeah. So my uv is actually cosine theta sine theta. I take your x and make it a theta. Cosine theta sine theta minus the integral of v, which was sine theta. What's du? It is minus sine theta d theta, right? Ah! I see the light at the end of the tunnel. And it is not a train. So that's good. So this is sine squared, right? Can you take sine squared theta and make it into something more interesting? Can you make it into cosine squared? We can. See, this is cosine theta, sine theta, plus the integral of 1 minus cosine squared theta, d theta. So the 1 integrates to theta. And then what do we got? It's the same algebra we just did, right? We started with what we're looking for, I. We got stuff. And minus I again. Right? Solve for I. What do we get? 1/2 stuff plus the constant. I mean, that's the same algebra we did in the last example. Let me be precise. Yeah?
Sorry, so if we get an integration by parts problem that keeps repeating like that, this looping, what do you call it, will generally work?
Yeah, what generally works is a good question, which I don't have a good answer for. I mean, I have some answer for. I'm about to tell you. It's a reasonable question that you're asking, because that's a hard question to answer, really, in totality. There's some patterns you can look for, but knowing how to integrate an expression and knowing when it's not possible, it's a bit of an art. it might be useful for me to just pause here for a second and say, the other way we could have done this would have been what? What was cosine squared theta? It was 1/2, right? 1/2 of 1 plus the cosine of 2 theta. In fact, I hope that if you face this integral, you don't do integration by parts. I'm showing you this to illustrate integration by parts and looping. I'm not endorsing this as the method to calculate cosine squared integral. Okay? This is the way to do the cosine squared integral. It's way faster, right? Because you write this down, and you're like, answer. Theta over 2 plus 1/4 the sine of 2 theta plus a constant, right? Are these the same answer? They don't look the same, yeah. Remember that formula we had for, what was it, 2 sine theta cosine theta is sine 2 theta, right? So if you multiply this by 2 and divide by 2, like this is 2 sine theta cosine theta divided by 2, this is actually sine 2 theta over 2. So when you multiply the 2 times 2, you get a 4th. It's the same answer. You're like, well, why are you showing me the integration by parts way if the other way is way faster? To try to teach you integration by parts, okay? Trying. Now, the question, how do you choose the u, right? There's this thing called Liate. Liate informs you as to the usually best choice of u. L stands for logarithm. I stands for inverse. A stands for algebraic. T stands for trigonometric. E stands for exponential. All right? And this is choice of u, or let's just say choice u. If there's a log, make it u. If there's not a log, but there's an inverse function, you make the inverse function u. Let's see how this works. Your question?
Yeah. Does it matter trig and exponential? Someone said that it doesn't matter if you do either one.
I think the way you could get into trouble here is if you first did it one way and then did it the other way, maybe you could have, I don't know. This is a guideline, it's not a law. And it doesn't make sense to me at all because logs are inverse functions and exponentials are inverse functions of some function. And I don't know, like I don't see these as mutually exclusive categories. It doesn't even make sense, this classification scheme. But whatever. Example 1, let's see how it worked. Was there a log? No. Was there an exponent? Was there an inverse function? Not as students usually see them, because when you guys think inverse function, it's got to have a -1 in it, right? So like inverse function, right? I'm sorry, I can't get it out of my head. E to the x is the inverse function of the log. These are the same categories. Sorry, I shut up. I'll shut up. It makes sense to you guys. Let me stop. So look at this. There's no log. There's no inverse. What's here? Algebraic. X is an algebraic function. All right? That's why we made u equal to x. Does that make sense? Okay. Example 2. There's no log. Inverse function. We made u inverse sine. We made u sine inverse. Liate 1. All right. Liate gave good sage advice. Here we have u. We have natural log. Liate says this is the king of all u choices. U is the log. Game over. It worked, right? Example 5. Cosine squared. Not log, not inverse, not algebraic. Trig. Oh, trig. I made. And see, this is where Liate lets you down. Should u be cosine squared? Or should u be cosine? I mean, it only gets you so far. you also need to know your basic algebra and trigonometric manipulations. I mean, there's more to it than that. Here's the first kink in the armor of Liate that I've shown you. Did this one work? I mean, what did I do? I picked u as the exponential. Oh, see, I should have picked, but it is true. If you pick cosine for u, you could flip and still loop back. Yeah, it's true. So what if we were to integrate? Example, where am I? 6, yeah. Here's one for you guys. Integral of e to the x. So we did e to the x cosine. How about e to the x cosh of x dx? What I would encourage all of you to do, take a few minutes tonight, maybe half hour, whatever, and just try to work about like 10 problems from section 8.2. I mean, you can work the ones in the mission, sure. But if those are too hard, start with the earlier problems, you know? See how it goes. Come back. If you don't understand, ask me questions about it. We have time for your questions in here, you know? If I'm going too fast, ask a question. There's no better way to slow me down than to ask me a question. I don't mind. This is a trap. Integration by parts is the wrong way to do this. What's the right way to do this? I think integration by parts would work. But here's how I would do this. This is the integral of e to the x times 1/2 e to the x plus e to the minus x, right? So this is just the integral of 1/2 e to the 2x plus 1/2. So it's 1/4 e to the 2x plus x over 2 plus a constant. Game over, end of story. No integration by parts, just basic integration guided by u substitution. So just because it looks like a duck, doesn't, it quacks like a duck, I mean, it might be a bomb. Sorry. Or an ice cream cone. I don't know, whatever you want. I mean, sorry, I mean, is it art if you hang it on a wall? Some people say art is eternal. Other people say art is an explosion. I think math is art, though. Math is the true art. Don't you think so? I mean, look, it's beautiful. There's so many different ways, but the answer is the same, but not the same, but you can prove it's the same, but I don't know, there's just so much here I love. But anyway, if you have not seen this before, this will take a few hours to get good at, right? And if you're shaky on that stuff, that makes everything we're doing today that much harder, right? If you're shaky on your algebra rules, that throws everything into chaos, right? So if you're uncertain about algebra, you should talk to me. I can try to help you. I know algebra, mostly. There's still algebra I'm learning, you know, but anyway, we've been in this hot room long enough. Let's leave. Thanks, guys. See you tomorrow.